here's the first question for this evening. So you guys can take your time, you can read through it, and then I'm just going to read through it myself quickly, and then we can get started. So guys, some little tips. When you are in an exam, you should read through this stuff, but don't go into it too seriously. Like, okay, they've given you a graph. C is the turning point. Great, we already knew that. It lies on the horizontal asymptote. The point is parallel to the y-axis. Don't get so intense about it. You just want to pick up the basics and then you move straight on to the question. So question 5.1 says, write down the domain of f. So graph f, let's go highlight graph f. Graph f is this one over here. And they would like us to find the domain. Now, can you remember last week Monday, I think it was last week Monday or the week before, we did a lesson where we said that we looked at the domain and the range of a hyperbola. And the domain is very easy to find for a hyperbola. You can say that x is an element of all real numbers except you cannot have the vertical asymptote. Now, the vertical asymptote is going to be this line over here. And the equation of that line will be x equals to minus 1. X equals to negative 1. That is the equation of that line. So for our domain, we can say that x is an element of R, but x cannot be equal to negative 1. Okay, so that's question 5.1 complete. 5.2, determine the x-intercept of f. That's very easy. Hey guys, to find the x-intercept, you make y equal to 0. So you can make y equal to 0. Then what I would do here is I'll take the 4 over. Then I would take this x plus 1 and I would multiply it over to the top. So that would go minus 4 bracket x plus 1 equals 2. And then I would multiply the 4 in. You can do this however you want, but I'm going to take the negative 4 over, so that'll become 6. And then if you had to go do all the dividing, you would eventually find that x is equal to negative 1.5. So that should be this point over here. And guys, when you get your answer in the exam, make sure that it makes sense. So for example, negative 1.5 is on the left of negative 1. So that does make sense. So always make sure that it does make sense in the exam. Okay. Now, so that's that one over there. Then it says calculate the value of k. So this is very easy. Can you see that this point over here, B, is already a point on the graph of f? So to find k, you simply plug that point in to the equation of f. So let me just clear this stuff up here, guys. So for question 5.3, I'm simply going to say that this point is on that equation. So I can substitute the y value as 14 over 3. And the x value, we can call that k, like that. Now, what I would do is I would take this plus 4 and I would take it over to the left-hand side first. So it would become 14 over 3 minus 4. And that gives us 2 over 3. So that's quite nice. 2 over 3 equals to 2 over k plus 1. Now, there are so many different ways that you would want to carry on now. Some students do one thing, some students do another thing. But what I like to do here is I just take this part at the bottom and I multiply it up to the top left. And I take this part and I multiply it to the top right. So that's cross multiplication. And technically you're getting a common denominator. That's what's actually happening. And so that should give us bracket k plus 1 equals to 2 times 3. And so that's going to be 2k plus 2 equals to 2 times 3, which is 6. 2k would be equal to 4. And then k would be equal to 4 divided by 2, which is 2. Okay, so now what they want, and just remember what we got for K. What did we get for K? We got 2, hey? Yeah, K was 2. Okay, so question 5.4 for 2 marks says write down the coordinates of C. So guys, have a look at this very carefully. C and B are above each other. So they would have the same X value. So the C value or the X value at C would also be a 2, but the Y value will be the same as the Y value on this dotted line. And that you can obtain from the hyperbola's equation, where you could say that y is equal to 4. So that means that the y value at C will have a value of 4. There we go, 2 marks complete. 5.5, determine the equation of G, which is the parabola, in the form y equals to that. Now, there are 2 ways to determine the equation of a parabola. You either use this equation, okay, or you use this equation. You can also put a plus, it doesn't really matter. Okay, you should use this one whenever they give you the turning point, and you should use this one whenever they give you the x-intercepts. So if we look carefully on this equation, let me quickly try something here. I want to just try using a highlighter. Oh, that's pretty cool. Okay, so if we look at that graph, we can see that at C, we have a turning point. So we should definitely make use of this equation over here. So what we do now is we say y equals to a. We don't know what a is. And then we're going to say x minus 2. Now, Kevin, why would you say x minus 2? The reason I'm saying x minus 2 is because I can see that this turning point has been, it's got a positive 2 there. And I know that it's always the opposite for the x value. And then for the y value, I would say plus 4. Now, to find a, we need to substitute in another point. But what a lot of students do is they substitute the point 2 and 4 again. And then there's nothing wrong with that, but it doesn't give you an answer. You're going to end up with something really weird like 0 equals to 0 or something like that. So you have to use another point that you haven't used yet. So check this out. It definitely goes through the origin over here. And they always tell you that in the exam, because some students are like, yeah, but how do you know that it really goes through there? So they will tell you if you are suspicious about that. So you fill in the point 0 and 0 because that is a point on the graph. So the 0 for the y, 0 for the x. Now, it's quite crazy. A lot of students, what they do, and you might have done this yourself, and it's okay, a lot of students do this by mistake. You combine all of this into one thing. I know some of you have done that. You combine all of that into one, but what you got to remember is that A is only in front of this piece over here. So this positive 4, take it to the other side, get rid of it. So it becomes negative 4 equals to A, and then 0 minus, and another common mistake is that when you guys type this in your calculator, you make a very small mistake by not putting it in a bracket on your calculator. And then it gives you a negative 4 instead of a positive 4. If you type it like this on your calculator, it's going to give you a negative 4. But if you put a bracket, which you should do, then it gives you a positive 4. Okay? And so there we have it. And then you divide by 4, and so A is negative 1. And it makes sense that A is negative because this equation is upside down. It's a sad face. So A should be negative. Okay. And so now we are nearly done. Just want to see, I've got a comment over here. Let me just see. Okay, so now we can put the value of A back over here. And so the final answer would be minus 1, that's A, x minus 2 squared plus 4. And so we are done. We don't have to go multiply all of this out because they've asked us to please leave it in the form like that. And so we leave it just like that. Okay, so let's clear up some space here because things are looking messy. Right, now I know that you guys struggle with these types of questions. A lot of students do, it's very normal. But let me try to show you a cool little technique that you can do. So I get asked a lot. Students always ask me, do you solve these types of questions by using the equations, or do you solve it by looking on the graph? 90% of the time you are going to look on the graph. You're going to look on the graph. You can pretty much almost do it 100% of the time, I would say. So let me show you a cool little technique. They are saying f of x divided by g of x must be smaller than 0. So it must be a negative. Now I want you to think of the absolute basics of maths. How do you divide two numbers and still get a negative? One of them has to be a negative, like that, for example, or maybe like that. But if both of them are a negative, then that all of a sudden becomes a positive. So we are going to look for areas on this graph, or on both of the graphs, where f of x, we're going to look for two different types of scenarios. We're going to look for places where f of x is a positive and g of x is a negative. And then we're also going to look for areas where g of f of x is a negative, and at the same time, g of x is a positive. The reason we do that is because then f of x over g of x should be negative, and f of x over g of x should be negative. Okay, so those are the areas that we are going to go look for now on the graph. So what I'm going to do is I'm going to focus on the first one for now. So let's highlight this for ourselves. Let's do this one. Okay, so what we're going to find is we're going to go and look for areas where f of x is positive. Where is f of x positive? F of x is positive. Okay, so let's see. Where is f of x positive? F of x is positive over here. Okay, and it's also positive over here. When they say positive, they mean above the x-axis. So that's where f of x is positive. Now, in the same place, where is g of x negative? Where is g of x negative? That would be over here. Let me use a different color. G of x is negative there, and it's negative over there. Okay, so we're looking for places where it overlaps. So where would it overlap? Well, we can definitely see that. Let me just get another highlighter. We can definitely see that this area up to here is really good, because this purple graph is also the purple graph is positive and the green graph is negative over there. So that's a good place. So we will definitely let me just see where else. Oh wow, it's actually very tricky, because okay, I see a lot of you are answering already. Guys, what we need to remember is that this graph actually continues. This graph over here, it keeps going. It doesn't actually stop. So it would also be negative over in this area over here, and this one is positive. So that's another area that we would also be interested in. So if I highlight the x-axis where all the answers would be, it would be this area here and this area over here. Okay, now what I'm going to do now is I'm going to look for this area. Where is the f of x graph negative and the g of x graph positive? So I'm going to quickly clean everything up a bit. Okay, so now we're going to look for places where the f of x graph is negative. So where is the f of x graph negative? Well, that would be, which one's f of x? Oh, it's that one. That would only be over here. It's only negative over there. Okay, and where is the g of x graph positive? The g of x graph is positive over here. That means above. So can you see that there is no area where f of x is negative and at the same time g of x is positive? There is no area where that happens. So this part does not work out at all. The only part we are able to find is in the first scenario that we looked for, okay? You might have to rewatch this again tomorrow and give it some careful thought. It can be tricky, and I would highly encourage you to try figure it out by yourself as well. It's very good practice. Okay, so now we need to give our answer. So we said that the answer is this interval over here. So that would be where x is smaller than whatever this x-intercept is. Now, did we work out that x-intercept? I can't remember. Yes, we did. We said negative 1.5. So x is smaller than negative 1.5 and equal to, or where's our other answer? Our other answer is over here. So we can say that x must be bigger than the asymptote value, which was, what was the asymptote value? Negative 1. Okay. We can't say bigger than and equal to, because the x value can never be on the asymptote. Let's just quickly see. That's actually a very good question. X bigger, yeah, x can't be -1 because that's the asymptote. And then x must be smaller than 0. Now, it's very important, and a lot of you might miss this, so be very, very careful. A lot of you might want to include the 0. You might want to say smaller than or equal to 0. But at that point, can you see that the graph of G will be equal to 0? And because the graph of G is at the denominator, and a denominator is never allowed to equal 0. So for that reason, we must not include the 0 over there. And so that would be our answer like this. X must be smaller than or equal to negative 1.5, or x must be between -1 and 0. For those of you that prefer to use interval notation, your answer would look like this. X is an element going from negative infinity up to negative 1.5, or x is an element going from negative 1 up to 0. Okay. Oh, wait, have I missed something? G of x is positive. I think I've also missed another interval, actually, where that one's positive. Yes, guys, I've missed one. Thank you. I think it was Barry who did that. And let me just see if anyone else got that one. Guys, well done. Absolutely well done. I didn't even pick up on this last one. There is another interval where g of x, sorry, that one didn't work at all. Where g of x is negative. So g of x is negative over here. Let me just get the yellow again. G of x is negative here. And then f of x is also positive over there. Can you see that? So that is also a very good interval. So we would also say when x is bigger than this value over here. Now, we haven't worked out that value yet, but that x value is going to be equal to 4. Yeah, so 0, 2, and then if you had to use symmetry, this is 0, x is 0 here. The x value here is 2. So if you use symmetry, this would be x equals to 4. So we can also say that there is a third little area where or x is anything bigger than 4. But you're not allowed to include the 4, because at the point where x is 4, the graph of G is 0, and that is at the bottom. So you can't include it, because then you would have an undefined. So you must say x is bigger than 4. Okay, so let me summarize our answers for us once more. So our first answer is x is smaller than negative 1.5, or x is bigger than -1, smaller than 0, or x is bigger than 4. If you prefer interval notation, we'll say x is an element from negative infinity up to negative 1.5, or from -1 up to 0, or from 4 up to positive infinity. Okay, quite a mess. I do understand that it's difficult to lay it out neatly. all the time, but you guys should definitely have another look at this question maybe tomorrow or when you have time, and try do it yourself before watching how we did it. Okay, challenge yourself. It's really a good way to become better at maths and at science. Okay, question 5.7, it goes on. Ooh, this one I actually did have a look at earlier today because it looked a bit weird. It's actually a really good question. And you might have found this one to be a bit weird. But let me show you. It's actually, there's a little trick that you do here. And once you guys see it, you'll realize, oh, it's actually quite easy. But if you haven't seen something like this before, you might find it very weird. Okay. So let's have a look. Use the graph of f and g to determine the number of roots. Roots are just like, okay, roots are just answers, pretty much, of 2 over x minus 5 equals to that. Now, what I want to remind you guys is the following. The equation of f of x was equal to 2 over x plus 1 plus 4. Now, let me just write that a little bit. I've got to squeeze this in here. F of x equals to 2 over x plus 1 plus 4. But now what I want you guys to do is I want you to look at this one over here. 2 over x minus 5. And I want you to think to yourself, how do you go from f of x to that one? So if you look here, it goes from x plus 1 to x. You might need to think about that for a little bit, but that is a translation of 1 unit to the right. So they translate 1 unit to the right. And then some of you didn't see this. Remember, this is a plus 4, and then it's going to a minus 5. So they moved it 9 units down. 9 units down. Okay. Now, what I want you to do is we're going to take a look at the equation of g of x. Can you remember what we got earlier? Let me do this in a different color. Promise you, once you guys see this, the way they do this question, they won't be able to give you another one like this, and you will see it. Like, they won't be able to trick you again. Can you remember what we got for g of x? We said x minus 2 squared plus 4. Remember that? That was the equation of g of x that we worked out earlier. Now, let me just quickly squeeze this in here. Minus 1 x minus 2 squared plus 4. And look what that gets translated into. That gets translated into this. Now, can you see that that goes from x minus 2 to x minus 3? So that's also 1 unit to the right. And also going from positive 4 to negative 5. So they've also moved that one 9 units down. So they have actually done the exact same thing to both graphs. So now, let me quickly show you guys something. They want to know, where are these two graphs equal to each other? That is, and roots are just the answers. So does it make sense to you that we don't have to look at the new graphs? We can just look at the original graphs because they're moving both of them in the same way. So we can actually just look at the originals, right? And we can ask ourselves, how many times would the original graphs intersect? They just remember that the parabola can go over the asymptote. It's only the hyperbola that can't. So this parabola actually extends forever and ever. Of course, they can't show us that. And so there will be an intersection over here. Can you see that? There is an intersection over there, but that is the only place where those two graphs will intersect. So how many real answers will there be? There will be one real answer. There is one place where those two graphs are going to intersect. I hope that that makes sense, that because both of the graphs are going 1 unit to the right and 9 units down, that does the same thing. So we don't have to redraw them, or we don't have to do anything. We can just look at the originals, because if you're moving both of the graphs in the same way, it almost cancels out. So you can just look at the original graphs and see how many times do they cut.